So we're starting page 2 of your notes, and what values can probabilities have? Well, if something's impossible, what probability? The probability is 0. All right? Can't happen. All right? And if something is 100% for sure, the probability is 1 or 100%. You can do probabilities as 0 to 1, all right? Or you can also do it from inclusive, by the way. Or you can do it from 0 to 100%, 0% to 100%. Okay? Just be consistent on whichever one you do. So if I have a 100% probability, or a probability of 1, that means that it is certain. It has to happen. Most of you somewhere in between these two. So the interesting problems are when the probability of X happening or A happening is between these two values. All right? Now, the probabilities for all outcomes in a sample space must add up to what? So, for example, if I said, what are the probabilities? Here we're rolling 2 die, right? What are the probabilities I'm going to get somewhere from 2 to 12 on rolling it? Did I include the entire sample space? I sure did. And hopefully you said that's 100, because all these probabilities for every cell on here has to add up, when I put them together, to 1. So the probability for the sample space, probability of sample space, has to be 1. All right? And that means the entire sample space, by the way. I should say entire. This does not mean that the individual outcome probabilities must be the same. For example, is the probability of rolling a 2, the sum of 2 die, and getting 2 the same as the probability of rolling a 4? No. There's only one way to get a 2 out of 36. But with a 4, there are 3 ways to get a 4 out of 36. All right? What's the probability of getting a sum of 5? Well, let's see. 1, 2, 3, 4. So there are 4 out of 36 ways to get a 5. What's the probability to get a 6 or a 7? Well, to get a 6, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I just add those together out of the 36 total ways, and then out of 36. What's the probability of getting a sum greater than 4? Well, that would be all these over here, right? And how many are over here? Well, I could count all of those, right? But some smart people go, wait a second. There are 6 over here, so I know automatically there are 30 left, right? So what they did is they said, I'm going to do 36 minus a 6 all over 36. And they got that. Okay, what is the probability of getting than or equal to 4? Well, here's the greater than 4, and here's the equal to 4. So I'm going to go to my answer for greater than 4 and add in the 3 that equal 4. And I get 33 over 36. So essentially, I know you've seen probability since middle school. And basically, the probability of an event, in this case, the red, is the number of ways to get red, or number of ways to get red, pretend n is number of ways, right? Over the total number of ways for the space, right? Now, here for time, what we can do is we can say, okay, we want a traffic signal to cross A.W. Grimes at Gallows Road has the following timing sequence. 20 seconds of green, 62 seconds of red, and 3 seconds of yellow. So let's say you come randomly in somewhere in this time frame. Well, what's the total time? It's 20 plus 62 plus 3. Okay, and what is the probability the light will be red? Well, how many seconds is the light red? 62. So your answer is 62 out of 85.